The first problem from this week's biweekly contest, find the original type string part 1. We are given a word and we are told that there are few mistakes. Uh, exactly how much mistake? At most once. Either of the character is typed multiple times. So since it's at most once, we can have this word itself as the correct word, or A, B, C, 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 C can be the correct word, or A, B, B, three C's, two C's, one C's, those all can be the correct words. We need to find the total number of possible correct words, right? So basically we are going to iterate and keep count of the consecutive characters, and that count we can use. If it is greater than 1, we'll keep adding to the answer, and initially the answer will be 1 because the correct word can be the word itself. So let's start. So since I need to keep track of the last character, right, every time, so I'll start from the first character and I'll keep track of it, and its count will be initially 1, and I will iterate from the first index, and that will be word dot length. I'll check if word of I is equal to last. If it is, then increase the count. Else, if count is greater than 1, then update the answer, right? So if count is greater than 1, initially answer will be 1. So if count is greater than 1, suppose C count is 4, then how many C's can be contributing to the answer? 1, 2, 3, right? So 1 less than the count. So I'll increase the answer by count minus 1, and resetting the count to 1. Actually, count greater than 1 is not even needed, because if it is 1, then I'll be adding 0. So that's not going to affect anything. Word of 5. And at the end, since I'll be iterating, the last character in this example C will not be processed. So I'll need to make sure I can do this as well. I is less than equal to word dot length, and if I is less than word dot length, only then enter here, else go here. Alright, so at this point I can just safely return answer. Space complexity will be constant, and time complexity will be linear. So the second problem, let's do it from the start. Find subtree sizes after changes. Right. So we are given a tree rooted at node 0 that consists of n nodes. So it's always rooted at 0, and it consists of n nodes. And we are also said that uh, every node is associated with a value. So 0, 1, 2, 3, 4, 5, and a character A, B, A, C, anything, and it can be repetitive. So we need to iterate, and every time I find a character, for example, here I find a character whose closest ancestor is also A. So this is the closest ancestor. Uh, the same character makes it the closest ancestor. So here 0 and 3 are the closest, and hence we need to connect that. So basically this will be connected and this connection will break. Alright, similarly here, the closest ancestor is this, but they are since already connected, so we don't have to worry about it. Similarly, B is already connected to its closest ancestor, so it's fine. C doesn't have any closest ancestor. What we need to find as an answer is basically a vector of integer which is of size n, and for every index, which is basically the node value 0, 1, 2, 3. There in the answer we need the size after all the breaking of connections and connecting the closest ancestor. Whatever the size of the subtree is at that particular point, that's going to be the answer. So here 0 will have a size of 1, 2, 3, 4, 5, 6, right? So 6 is will always be the size for the root. Actually, for the root, n will always be the size, right? Similarly, the next one will be 3. So 0, 1. So this is what we're talking about. Since this connection will be broken, 1, 4, and 5 will be the three nodes contributing to this answer. And similarly, 1, 1, 1. How can we do that? How can we solve this? We can just do a DFS, right? A DFS, a DFS here. By the way, we are not given a tree, we're given a parent. So we can create an adjacency list. Since it's not a binary tree, it's a tree, we can create an adjacency list. For every node, I will keep track of the closest ancestor in form of a map, right? Because character to integer will, be the data structure. So let me write the data structure here. Closest ancestor will be of a map, unordered map, character comma integer. Why character comma integer? Because every time I am at A or here the third node, I will check in the closest ancestor if there is any character of A already existing. If there is, then I will connect to that. Alright, so that node will be here. And finally, if I'm missing anything, I don't think so. So DFS, simple DFS and backtracking. So that I'll go here. I should, adjust closest ancestor accordingly. So backtracking and DFS, we can do this problem. I will need a, closest ancestor, like I said, and I need to pass it to the DFS function. So I'll declare it outside. Let me call this closest instead. And similarly, vector of answer will be needed. We'll declare it here. What's this number of nodes? That is going to be parent size. Now we need to create the adjacency list. So that will be of vector of size n, since there are n nodes, and I will iterate through the parent vector. Here I will update the adjacency list. Since from the parent I always need to go down, so it's always going to be unidirectional. Parent of I'll go up with the help of the stack of the DFS call. So I don't need to keep track of the uh, other direction. So it's not going to be bidirectional, it's going to be unidirectional. And the parent of I will be here. So this represents the parent. All right. And since this 0 can be negative, so I need to be careful and yeah, I need to be careful and start from 1. Alright, and I guess I need to resize my answer because I I need to store n answers here, and I'll call the DFS function. What I'm going to pass here is the adjacency list, the string, and the node from where I'm going to start. So since it's always going to be rooted at 0, so I can mention 0 here and return answer. Let's define the DFS function. DFS will return the size of this particular node. Whatever node at which I am, I'll call the DFS function on that. So that will return the size of the subtree. So it's going to be integer. And here I will pass the first thing, that is adjacency list, and the string, let me pass it by reference. At this point I will, since this particular so I will need to have a subtree in which I'm going to store, that's basically going to be my sub answer. So subtree is equal to initially the value should be 1, because if I have a node, the node itself is going to be contributing to the answer. That's why I'm going to start with 1. Now I'm going to update. So every time I call the DFS function, I'm going to update the ancestor, the closest ancestor of the closest map with the current character value with its node. Alright, so closest uh, of S of node. So this is going to be representing the character that the node is having with its node as the value. That's going to be updated, and now I'm going to iterate over their children. The child node, let's extract a variable adj of node of I. At this point, I have two choices based on what. So the first choice will be I have not found, for example, here I have not found any character that is present inside closest map. So if closest map or the closest variable dot find s of child node, so if this character is not present in closest, or there's going to be another condition, and that is going to be a case where if it is found that there is a character, but that's the parent itself, so I don't need to do anything. Okay? So that is also going to enter this case where the character is found, but it is equal to the parent. So this is the this is the parent mode and this is the child mode. So at this point I am going to call the DFS function, which is going to be this DFS of adj comma s, comma child node. This time I'll pass this child node and the story will go on. Else, what should I do? Else, basically, I am having a scenario where this is the node that I'm standing on. So I need to break this connection, right? This joining it doesn't need, it's not going to, affect anything because uh, anyways, 0 is going to have both 1 and 3 as its contribution, right? So connection I don't need to do in terms of the adjacency list, but I need to break this connection, right? So instead of adding subtree, adding to the subtree, which is going to be this one. So this is what subtree is going to account for. Instead of that, I'll straight away update the answer. So answer is accessible here. I've declared it outside. So how uh, answer is going to be updated? So whatever node that is inside closest. So 0 of A is inside closest, right? Or A of 0 is inside closest. So the node will be closest of S of node, or actually child node, plus equal to dfs of adj s. Now I'll call for this child node, right? Child node. So I'm adding straight to the answer instead of adding to the subtree, which is for B. So B is going to have one less. This one won't be counted inside subtree of B or subtree of node 1. Alright. Now I need to backtrack, right? How am I going to backtrack? What exactly I need to backtrack? Closest map is what I need to backtrack. So I must store whatever I'm going to update here so that I can backtrack it later. So I am going to have something like a previous closest, right? Which is initially -1. If closest does have the s of node, if this character is there, then um, dot end. In that case, update the previous closest first so that I can later use the value to backtrack it. So closest of s of node, and here I can use or check if previous closest is indeed not -1 now. If it is not, then update closest back to that value. Otherwise, if previous closest is still -1, which means this was not even existing, right? That's why it was -1. So I will erase this so that the previous state is retained. Alright, and finally I'm going to update the answer. So answer for every node. So what am I going to return? I'm going to return whatever node I am here at, whatever is its size, right? So that is already updated, or I'm going to update it using the subtree. So answer of node plus equal to subtree. So my size is now updated, and that's what I'm going to return. All right. Let's see if this works, or if there is any mistake. If this does work, in terms of time complexity, we are going to iterate through all the nodes, and that's why it's going to be O of n, and space complexity will be O of n because there is going to be stack space and we have adjacency list as well. So yeah, that's the second problem. The third problem, maximum points tourist can earn. We are given n and k integers and 2D integer arrays, stay score and travel score. Alright, we are basically told that we have a rule or a two choice that the tourist can make, and based on that he will be assigned scores using the two arrays that we are given, travel and stay. And we need to find the maximum possible point that the tourist can earn. So first choice is stay in the current city. If I stay in the current city, then my score is going to be the stay score for the particular ith day. So there's going to be few days that is going to be k, exactly k days, and the current will be the current city at which I am starting from. I can start from any city and I can travel, so my current city will also change accordingly, and that's going to be decided based on my decision, the traveler's decision. So move to another city, that's the second choice, and for that my travel score will be the score. So this is the city at which I'm starting from or I am at, and this is the destination. So we basically need to do a DP, right? It's pretty straightforward in terms of intuition. So we are going to do a two choice, either stay in the city or move to another city, and based on that we need to keep track of the maximum score at every decision. Alright, so uh, initially I can start from any city, right? So if I'll try to start from every city and get the maximum answer from all of those trial. Alright, so my initially I will start from every city. So I have n cities. So I'll start from every city. It's zero index, so 0 to n minus 1. Result is where I'm going to store it. So I'll declare a result, a global result. Here I am going to have a max of result comma a dp function or solve function. So this is going to have some parameters. And here I am going to return or result. What do we need as the parameter? We are going to return integer solve function. So we need the city. So whichever current city I am at, so that is going to be I. So every city I'm traversing, and so I'm starting from I. How many cities are there? So n cities. How many days I have? So k days I need to pass. I need to pass stay score and travel score as well. Stay score and travel score as well. And this is the current city, but I also need the current day at which I am. Initially it will be 0. So the current city, current day, uh, n. So I'll pass it with reference. I don't think it matters, but and k as well. Stay score. Let me take this, paste it here. Alright. So at this point, what's going to be the base case? Well, if the current day is the last day, in that case, so k is also I think zero index. Yeah, k is also zero index. So k is K means that I have exceeded all the days. So if there are 3 days, so I'm at the fourth day, right? So 0, 1, 2, 3. Actually, I'm at the third day, but it's from zero index, so I'm at the last day. Already stayed all the days that I can. Current day, in that case, return 0. Alright, and I am going to have an answer initially 0. So the first choice will be stay. Alright, this means that I am going to update the answer with a call to the solve function. But before that, what's the score that I'm going to add? So stay score will be the score from which I'm going to assign the score, the current day. So I will be the current day and the current city. Alright, plus the remaining days, whatever choice I make, I will call the solve function again. So current city, current day, but this time the current day will increase by 1. So I have stayed 1 day. So n will be still n, k will be k, and stay score and travel score. Let me copy this. Okay, all right. The second choice will be travel. Right. So travel can be to any city, right? So I am going to do a brute force to all the cities. Int I is equal to 0, I less than n. It can be a city that I have already been to, right? Uh, but it shouldn't be the city that I am already at, isn't it? Because in that case, I can have that, but I'm just uh, let's not have that. To make it more efficient. If this is the city I'm already at, avoid calling the solve function again. If it is not, then call the function. Now answer is equal to answer max of answer comma this time travel score. Let me just copy this. This time it will be travel score from the current city to the destination. This time the current city will be still current city, they will increase by 1, n and k will still be same, all the things will still be same, and I'm going to return the answer here. Let's see if this works. We need to minimize it. So this is going to be a solution, the bottom or sorry top down solution. Now we are going to minimize it. We have two states, current day and current city. So in terms of constraints, 200. So 201 is what we can take, vector of and let me declare it here so that I don't need to pass it. Cache and right here cache dot resize n plus 1 n plus 1. So 200 is not needed because there are n cities, so I can just have n plus 1, and the second will be those many days, so k plus 1. Initially it will be minus 1. So if cache of current city and day is not equal to minus 1, then return cache of current city and day. So I can just initialize this here. And let's see. Hoping this will work. In terms of time complexity, we have two states. So O of n square, sorry, O of n into k. Oh, sorry, this is current day. And space complexity will be again O of n into k. Okay, something is not right. Not equal to -1. Travel score, current city to I, and current day to current city. Answer is equal to t square. Okay. Is it because actually I might need to uh, have this scenario as well, but I don't think so. It's going to matter. Let's see if there is something else that's missing. N plus one. Oh, okay, my bad. So we need to travel to all the cities, so all possibilities. And in terms of okay, n plus one and k plus one. That's correct. So right here, stage score is already added, and I'm increasing the day. Oh my bad. I'm not passing the correct city. So my current city will change to I now, and that's the problem. I don't know why this was working in the original test cases, but still, that's my mistake. I think I should also add that back. Okay, current city, current day. This will be I, and now that's it. In terms of space and time, that will be O of n into k, and that's the third problem. Thanks.